So here we're going to do our second part of our trigonometry review. We're going to look entirely at inverse trig functions. Scrolling down for just a moment before we look at this unit circle. The first idea that we really need to have squared away is that an inverse trig function gives us angles, right? In other words, when we plug in a value within the domain of an inverse trig function, the answer represents an angle. And so we are going to use this notation here for our inverse trig functions. We're only going to look at sine inverse, cosine inverse, and tan inverse. And you'll notice that in each case, I'm writing these sine inverse equaling theta, theta being an angle, same thing with cosine inverse equaling theta, and tan inverse equaling theta. And we'll go ahead and fill this out in a moment, but first I want to go up here and I want to take a look at our unit circle that's missing quadrant 3. And this may not be exactly how you've done it in the past, but I found that this is a pretty efficient way of kind of thinking about it and visualizing what's going on. So what we're going to do first is we're just going to go ahead and fill in quadrants 1 and 2. So I'm going to start with degrees and radians going around. So here's 0 degrees, 0 radians, 30 degrees, pi over 6, 45 degrees, pi over 4, 60 degrees, pi over 3, and so on. All right, so we've got that. And we can also put the values going all the way around, just like we did with the entire unit circle. And then we'll see how this unit circle kind of differs from what we did before. So nothing changes here, really. Okay, now looking at quadrant 4, instead of using our positive angles that we used last time, right? An angle going maybe all the way around here, 11 pi over 6. Instead, we're going to say we've got negative pi over 6 here. And there's a reason for this, and we'll talk about it in a little bit, but we're going to identify all of these acute angles in quadrant 4 using negative angles like this. So negative 30 degrees, negative 45 degrees, or negative pi over 4, negative 60 degrees, or negative pi over 3, and finally negative 90 degrees, negative pi over 2. And we're going to get the same values here, which is kind of nice. And just like that, we've recreated the top half, the right quadrants 1 and 2 of our unit circle from before, but we've done something a little bit different with quadrant 4. And we're completely ignoring quadrant 3, and we'll see the reason for that in just a moment. So from here, looking at our inverse trig functions. Now, I'm not going to go too much into the reasoning why these are defined the way they are. If you want background on that, by all means, come see me. We'll talk about it. It's discussed in detail in a trig class or in a pre-calculus class. But for us, we just want to make sure we remember the domains and ranges of our inverse trig functions. So inverse sine, or sine inverse, which we're going to denote sine inverse, as you see here, sine with that -1 and or arc sine. It's only defined for x values between -1 and 1. Now, we say that sine inverse of x is equal to theta if and only if two things are true. The first one is that if we took the sine of theta, it would equal x. And our angle theta is restricted between negative pi over 2 and pi over 2. Like that. And so before we go on to the others, I just want to go ahead and take a quick look at what this means. First of all, negative pi over 2 to pi over 2 is negative 90 to 90, right? So let's go ahead and do this one in blue. I'm going to highlight here for sine inverse. So sine inverse of theta has thetas always between negative 90 and 90. What does that mean? It means we can go from 0 in this direction to negative 90, or we can go in this direction to positive 90. And so our answers, our angles that we get from a sine inverse, are always going to be in quadrants 1 or 4, but the angles in quadrant 4 have to be negative acute angles. Remember, an acute angle is an angle between 0 and 90, and they're going to be negative to get us into quadrant 4. So that's what we have going on with sine inverse. Cosine inverse is a little bit different, though. So cosine inverse, if we have cosine inverse of x equaling 0, as you see here, that means that cosine, I said 0, my goodness. Cosine inverse of x is equal to theta, I should say. That means cosine theta is equal to x, and theta in this case is between 0 and pi. Okay, this is agreed upon amongst math people, engineering people, whoever's doing trigonometry out there, and it's already programmed into all of our calculators and computer programs and whatnot. So now we're going to look at cosine inverse. Notice here that the answers we get, the angles that we get, are always between 0 and pi. So we're always going to get answers between here and here for cosine inverse. Finally, tangent inverse. We'll do this in, So tan inverse x equals theta means that tan theta is equal to x, and theta has to live between negative pi over 2 and pi over 2, and it doesn't include negative pi over 2 or pi over 2. It has to do with the graph of the tangent function, turning it into an inverse, and the vertical asymptotes of the tangent become horizontal asymptotes of the inverse. Again, if you want the details, come see me, we can talk about it, but this is just kind of a quick review so we can evaluate these things. And so our angles that we get from tan inverse are going to be kind of similar to what we have for sine inverse. We're going to be between negative pi over 2 and pi over 2. Okay, and so what you'll notice when we look at our green, our blue, and our purple in the unit circle, we never get an angle in quadrant 3. So for inverse trig functions, we're never going to get results in quadrant 3. All right, so what do? We need to be able to evaluate these guys. And so what I've done here is I have included a nicer, easier to read unit circle, okay? But of course, it's got some problems with it if we're going to use it for inverse trig functions. So the first thing I'm going to do is I'm going to turn this into negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. We cannot use those other values because they are outside of the ranges of our inverse trig functions. And of course, negative 30 degrees, negative 45 degrees, negative 60 degrees. It's a little sloppy, but hopefully we've got that all in there. And then with this part, we don't need it at all. So I'm just going to take a white pen here and try to make it just disappear. It's not really white, but it's going to have to be good enough. All right, because we're not going to need it. From there, just to get my color scheme correct, our sine inverse is going to go between negative pi over 2 and pi over 2. Our cosine inverse is going to go between 0 and pi. And our tan inverse is also going to go between negative pi over 2 and pi over 2. In other words, as we look at the problems that we're about to evaluate, the inverse trig functions that we're about to evaluate, notice all of these are sine inverse. So they're going to give us answers in the blue region, whereas all of these are cosine inverse, which they're going to give us angles in the green region. And finally, I guess I'm doing purple, tan inverse like that. Okay, so let's go ahead and evaluate these and see how it works. So looking first at sine inverse of a half, we're looking in the blue region. Remember, sine is the y value on our unit circle. So I would say right here, I've got a y value of a half, and it's in one of the light blue quadrants, and so that should be pi over 6. That's a 6. All right. Looking at the next one, sine inverse of negative root 3 over 2. That's right there, a y value of negative root 3 over 2. And even though we wrote all this in red, I'll tell you right now, the most common incorrect answer I get here is 5 pi over 3, right? Oops, 5 pi over 3. That's outside of the range of our sine inverse function. So it needs to be negative pi over 3. Oops. Okay, next one, sine inverse of 1. So looking for a y value somewhere in the blue, one of the two blue quadrants that has a y value of 1. That only happens right here. And so we get 90 degrees or pi over 2. And there we go. Next, we'll switch over to cosine inverse. We're now either in quadrants 1 or 2. I'll just quickly state this problem didn't specify whether the answer should be in degrees or radians. Usually I prefer radians. I shouldn't say I prefer. We prefer in calculus, we prefer to do things in radians. That said, usually I'll specify what I want. Anyway, cosine inverse of root 2 over 2. Here, cosine, as usual, is an x value, and we have root 2 over 2 right there, which is going to give us pi over 4. Next one, we have negative a half for an x value. That's going to give us 2 pi over 3. Next one, cosine inverse of negative 1. That means our x value is negative 1. That happens here at pi. And so notice all three of those were entirely in the green region. And these won't change, right? The ranges, the blue, green, and purple that you see on the graph, those won't change for sine inverse, cosine inverse, and tan inverse. And again, as I mentioned earlier, they're all programmed into your calculators. They're programmed into every computer program that uses an inverse trig. Next, tan inverses. So we're looking at tan inverse of root 3. Now, these are a little more tricky because we can't just take an x or y. We've got to think about it as y over x, right? Sine over cosine. So first of all, notice that we have a positive value that we're taking the tan inverse of. So that means we're going to be in quadrant 1. And if you wanted to, I do this with my trig students, I have them write the tan values beside each point. So for example, at 0, well, real quick, tan of an angle is defined as the y value of the point on the unit circle, or, well, anyway, the y value on the point of the unit circle over the x value. So tan here is going to be 0/1 at 0. Tan at pi over 6 is going to have the y value over the x value. And if we multiply top and bottom by 2, we have 1 over the square root of 3. So I'm going to put 1 over root 3, which rationalized is root 3 over 3. If I put, for pi over 4, if I put y over x, I'm going to have a number over itself. So that tan value is simply 1. For pi over 3, if I put root 3 over 2 over 1/2, I'm just going to have root 3. And of course, if I put 1 over 0 here, I'm undefined. And the same thing happens in quadrant 4, but they're all negative. So here we'll have negative root 3 over 3. Here we'll have negative 1. And here we'll have negative root 3 and undefined again. Okay, so those are the tan values in those two quadrants. So once we have those down, it becomes much easier to quickly see how to deal with these guys highlighted in purple. So I'm looking for a tan value of root 3, and we see that right here at pi over 3. Looking at the next one, tan value of -1, we see that right here in quadrant 4. That's going to happen at negative pi over 4. Again, 5 pi over 4 would be the wrong answer here. It has to be a negative acute angle. And then this next one, we have negative root 3 over 3, which is right there. And so that's going to be negative pi over 6. And there it is. That's how we're finding our inverse, or evaluating, I should say, our inverse trig functions. Go ahead and do the rest of these on your own using this version of the unit circle, and you should be in pretty good shape. Again, these just like before, this trig stuff requires quite a bit of practice. It's a matter of doing tons of it, and the more you do it, the more fluid it gets and the easier it gets. We will need to evaluate and understand inverse trig functions as we continue through the course.